discuss a chapter, similar triangles or triangles, which is chapter 6 of class 10. In this chapter, we are going to discuss the exercise 6.5. In this exercise, we are going to deal with a few problems in the beginning, 1 to 3, in this particular video. And in the next video, we'll discuss the rest of the example. So, if you look at this exercise 6.5, you will realize that there are basically two concepts over here. First, we'll discuss the concept and then we'll try to dive into the problem. Okay, so let's say you have a triangle ABC. Which is right angle at 90 degree. So from Pythagoras theorem, we know that AB square plus BC square equals to AC square. Even the converse of the theorem is, it's more like if angle B is 90 degree, then this is true. And the converse of the theorem is, if AB square plus BC square equals to AC square, this implies angle B is 90 degree. So this is first, this is second. And most of the problems will be dealt with using these two theorems. So let's start with this first problem. It is saying that sides of the triangle are given below. Determine which of them are right angles. In case of a right angle triangle, write the length of its hypotenuse. So there are three sides which are given. We need to figure out whether it's a right angle triangle. So what we need to do, we have to see here that there will be a side which will be bigger than other two sides. And invariably, if it is to be a right angle triangle, this side, the bigger side, will be the hypotenuse. So we'll have to figure out, we'll calculate the other two sides and the square, and then see whether it is equal to the third side. So in either way, you have to calculate all the sides. So we will assume that AB square equals to 7 square, which is 49 in the first example, and then BC square equals to 24 square, which is 576. Now, when you add AB square plus BC square, it will be 49 plus 576, which is nothing but 625. And when you calculate this 25 square, and we'll call it AC square, then it will be 25 square, which is nothing but 625. So in this case, what will happen here is that AB square plus BC square equals to AC square. This implies that angle B is 90 degree. So yes, this is your first problem. Now let's take the second one. So as we said, the smaller sides will take as AB and BC. So we'll take AB and BC like this. So we'll take AB square equals to B square equals to 9, and then similarly we'll take BC square equals to 6 square, which is nothing but 36. Now we'll calculate AC square, which is nothing but 8 square, which is 64. So when we sum up AB square plus BC square, we'll get 36 plus 9, which is 45. So we can see here that AB square plus BC square is not equal to AC square. We can write AB square plus BC square is not equals to AC square. So this means that angle B is not 90 degree. Coming to the third problem, again we'll take the two sides, smaller sides of AB and BC. So we'll take AB equals to 50, and so AB square becomes 50 square, which is nothing but 2500. Similarly, if I take BC square equals to 80 square, which is nothing but 6400, we'll take AC square equals to 100 square, which is nothing but 10,000. Now when we sum up AB square plus BC square, we'll get 2500 plus 6400, which is nothing but 8900. So again AB square plus BC square is not equal to AC square. So this implies angle B not equal to 90 degree. Now coming to the fourth problem, which is again 13, 12 and 5. So we'll take the two smaller side 5 and 12. So we'll take AB as 5, BC as 12 and AC as 13. So what we will get is AB square, which is nothing but 5 square equals to 25. We'll get BC square equals to 12 square, which is nothing but 144, and then we'll get AC square, which is 13 square, which is nothing but 169. So we'll get AB square plus BC square equals to AC square. This implies angle B is 90 degrees. Alright, so yeah, in this way we can say that first and fourth are right angle triangle, and we had to find length of hypotenuse in each of the cases. So we can say that length of hypotenuse in this case A is AC is hypotenuse, and that's 25. And in the other case we have again AC equals to 13. So this is my hypotenuse. Okay. So these two are my hypotenuse. In other cases there is no hypotenuse, right? So yeah, we are done with problem 1. Now we'll go to problem 2. Problem 2 talks about PQ is a triangle right angle at P and M is a point on QR such that PM is perpendicular to QR. So show that PM square equals to PM into MR. So let's first make a right angle triangle here. So this is my one side, this is my another side, this is my third side. So we'll call it A. Oh, sorry, we don't have to call it A. So PQR is a triangle right angle at P. So P is here, a right angle at P. Then we have a Q, then we have a R. Such that now M is a point on QR such that PM is perpendicular to QR. So now there is a perpendicular drop from here to the other side. So we'll take another line which is perpendicular, right? And so now this is perpendicular and this point is M. Now PM is perpendicular to QR. So that PM square, we have to show this PM square is equal to Q1 into MR. PM square equals to Q1 into AR. So can we write PM square as PM by QM and this MR by PM? Can we write this like this? So what we have done is we have sent one PM to the other side because it's a cross multiplication. So now when you look at this, you get some idea. When you are looking at it, it's PM and QM. So PM is here and then QM is here. When you look at MR is over here and then PM is over here, right? So looks like we are talking about this triangle and this triangle, right? So we got to go into these triangles and then see whether these can we get something out of these triangles. So we have learned that if there is a right angle triangle and we draw a perpendicular like this, then what we get is this triangle is similar to the bigger triangle. This smaller triangle is similar to the bigger triangle, as well as these two smaller triangles are also similar. That is what we have learned earlier. So using this similarity condition, we know that triangle PMR is similar to triangle PMQ. When we have this similarity condition, what we can see over here is that we can have the sides like PM, which is opposite to this angle R. So PM is to, in this triangle, this PM is opposite to this angle. Now we got to see that which side we should be taking as the opposite side, right? So before going there, what we can do is that, assume that this is my angle theta. Let's assume this is my angle theta. What we can write over here is this is my 90 degree minus theta. Why so? Because in this triangle, all three angles will sum to 180 degree. So this is theta, this is 90 degree. So this is 90 degree minus theta. Since this angle is 90 degree minus theta, this angle will be theta because overall this angle is 90 degree, right? Since this angle is theta, this angle is 90 degree. So this angle is 90 degree minus theta. So now we can say that this angle R is equal to basically P angle, right? So when we have taken a side which is PM is opposite to 90 degree minus theta angle. So we have to take a side which is opposite to 90 degree minus theta, which is going to be this side. So we have to take PM is to NQ. Similarly, we have to take basically MR. MR in this triangle is opposite to theta angle. So we will take MR, and in the other triangle, is the smaller triangle. Again, what is the side opposite to theta? This is theta. So MPM is the again side opposite to theta, right? So this is what we got. So we can write again cross multiplication. We can write PM square equals to MR into QM. This is what we had to prove, right? So we got it. So if you guys have not understood how we got this angle 90 degree minus theta and how this theta, let's do this part again. We'll call angle Q plus angle QPM plus angle QMP equals to 180 degree. In a triangle, all these three angles will sum to 180 degree. I'm calling Q as theta, and QPM we need to find out, and angle QMP is 90 degree. So this is 180 degree. So QPM will be again it will be 90 degree here, and then theta will come over here. So 90 degree minus theta. So this is how we got this 90 degree minus theta as usual, right? So this finishes our second question. Now let's move on to the third question. Alright, let's move on to the third question. So what is my third question? Third question is this. In third question is saying in figure 6.53, figure is already given. AB is a triangle, right angle at A. So basically this angle is my 90 degree, and AC is perpendicular to BD. Again, AC is perpendicular to BD we are getting. We have to show that AB square equals to BC into BD. So we'll do the same thing what we did in the first example, in the previous example. So let's first write out what is given. It's given AB square equals to BC into BD. This is what is given. Can I write this as AB by BC equals to BD by AB? We can write that, right? I've just did a cross multiplication. Now looking at this expression, we can figure out which triangles we have to work with. So AB and BC. So we are getting AB over here and then BC over here. So this triangle, smaller triangle again, and BD and AB. So we are getting BD. This is a bigger triangle, and then AB, again the bigger. So it is looking like we need to deal with this smaller triangle and this bigger triangle. And as we have discussed earlier, we know that triangle BAD would be similar to triangle ACB. Right? We got to now see again the angles part. So if we call it as theta, we know that this angle is my 90 degree minus theta, which is 90 degree minus theta. So this angle is theta, and since this angle is theta, this is 90 degree. Again, this angle is minus 90 degree minus theta. Alright, so now let's work with triangle BAD. When we are working with triangle BAD, we know that we need to get AB and BC. So we need to get AB. So AB is opposite to AB is opposite to what? AB is opposite to 90 degree minus theta. So in this smaller triangle, what is opposite to 90 degree theta is BC. So So we'll write AB is to BC. Similarly, we need to get BD. BD is opposite to 90 degrees. So this is BD. We'll write BD. And then we got to work with what is opposite to 90 degree in this, which is AB. So this is AB. So from similarity condition, we can write that since these two triangles are similar, the sides will be in this ratio. So we got this first part. Now let's work with the second part. What is my second part, which is talking about AC square equals to BC into DC. Now again we'll do the same thing. What we'll do is we'll put AC is to BC and then DC is to AC. I've just did a cross multiplication. If you don't understand, AC square is written as AC into AC, right? So this is what it is. Now look at this AC BC. We have got AC, we have got BC. So we have got this smaller triangle. We have got DC, which is again this side, and we have got again AC. So looks like we have to deal with these two triangles, and as we know, these two triangles are also similar. So we'll write triangle ACB is similar to triangle ACD. This implies that in this triangle AC, which is opposite to theta degree, so AC divided by what is opposite to theta here is CD. So we'll write AC upon CD or DC, whatever it is, equals to, we have to get another one as BC because DC we have got BC. So BC is opposite to 90 degree minus theta, so we write BC, and then what is opposite to 90 degree minus theta over is AC, so we got AC over here. So again we'll do a cross multiplication like this, so we'll get AC square equals to BC into CD or DC. You can write BC or DC, BC into DC. Alright, so this is what we have to prove. The second one is also done. Now let's work with the third one. Third one says AD square equals to BD into CD. Alright, now again what I'll do is I'll put AD by BD equals to CD by AD. So this will again let me understand what triangles we are dealing with. So AD and BD. So AD is this and BD is bigger one, looks like. CD is this and AD is this. So bigger triangle and then ACD triangle we are dealing with. So again we can write triangle BAD is similar to triangle ACD. When we write that, we can write this now. So in AD is this bigger triangle. If we are looking at this bigger triangle, we are getting AD, which is opposite to theta angle, so we'll write AD. And then in the smaller one, again what is available against theta, which is CD, so we'll write CD. And then we have to work with BD because BD is there. So now BD is opposite to what? 90 degree. So we'll write BD over here, and then we will have to write what is opposite to 90 degree, which is AD. So we have to write AD. Now do a cross multiplication. Again you get AD square equals to BD into CD. So yeah, this is what we had to prove. So yes, all these three questions are done using the similarity condition. Since these triangles are similar, then we have arrived at these results.
I'm going to discuss problem number 4, 5 and 6 of chapter 6 and this is exercise 5.6. Alright, so we have already discussed problem 1, 2, 3 in the previous video. In today's video, it will be for 4, 5 and 6. So let's start the class. So this is the first problem or the fourth problem. ABC is an isosceles triangle, right angle at C. Prove that AB square equals to 2AC square. So this is a very simple problem. First of all, let's try to make a figure. So this is my, say, right angle triangle. I have created a right angle triangle, and this is my C, because this is at right angle at C. So now call it A, B and C. So from Pythagoras theorem we know that we know that BC square plus AC square equals to AB square. Also it's given that ABC is an isosceles triangle. Prove that. So if it's an isosceles triangle, we know that only this side can be equal to this side. Hypotenuse cannot be equal to any other side. Alright. So if BC is equal to AC, we can write over here BC square and another BC, or rather BC square also we can write again, and then we can write AB square. And then again we can write 2BC square equals to AB square. We can as well write AB square equals to 2AC square. Alright, because BC equals to AC, right? So here itself you could have written AC square plus AC square instead of BC square, and you would have got the result. So this is what we were supposed to get, and we got it. Alright, let's go to the next problem. What is my next problem? My next problem is this one. Let's go to my next problem. The next problem is it's calling where ABC is an isosceles triangle with AC equals to BC. If AB square equals to 2AC square, prove that ABC is a right angle triangle. So again, it's a converse of Pythagoras theorem, wherein we know that if in a right angle triangle, if let's say you have a right angle triangle like this, and your AC equals to BC, if we know that BC square plus AC square equals to AB square, we know that angle C is 90 degree, right? So let's see, if that being the case, then this implies this, right? So in this case, what has happened here is that we have got AB square equals to 2AC square, right? And we can write 2AC square as AC square plus BC square, or rather let's do it in two steps. We can write it as AC square plus AC square, and since AC is equal to BC, so we can write AC square plus BC square since AC equals to BC. So now what we have got is AB square equals to AC square plus BC square. This implies that angle C is 90 degree. Alright, this is also a simple proof. This is a converse of Pythagoras theorem. Alright, now we can go to the next problem, which is this problem. So okay, in this problem what's being said is ABC is an equilateral triangle of side 2A, find each of its altitude. Alright, so let's create an equilateral triangle. Alright, so this is an equilateral triangle ABC, and now we need to find each of its altitude. So what it is saying here is that there is an altitude drop from here to here, here to here, and another one here to here. So these are altitudes, so D, E, F. So and then it's also given that this is 2A, this is also 2A, and this is also 2A. So with respect to symmetry, we know that if we find out one of these altitudes, the other altitudes will be also equal, right? So now let's try to look into this triangle ABD and ADC. So let's call this BD as X, and then DC as say 2A minus X, because this entire length is 2A. So if this becomes X, then this will become 2A minus X, because when we sum it up, it will be 2A, right? And then let's assume that the height AD equals to H. So from Pythagoras theorem, we know that in a right angle triangle, in triangle say ADC, we know that my AD square plus DC square will be equal to my AC square, right? And AD square is nothing but let's call it P, just not to get confused. So we'll call it P. Alright. So we call it P. So P square plus DC square equals to AC square. And again, sorry, P square plus 2A minus X whole square equals to AC is nothing but 2A whole square. So this is 1. Similarly, if we go in triangle ADB, we can get AD square equals to AD square plus we'll get AD square plus BD square equals to AB square. Then AD square is nothing but P square plus BD square is nothing but X square, and then AB square is nothing but 2A whole square. This is my equation 2. Now I will put from 1 and 2. I'll use P square from here and put it over here, or in any way around. So I'll use a P square from here and put it over here. So I'll use P square as 2A whole square minus X square from this equation plus 2A minus X whole square, which is this part, equals to 2A whole square, right? This and this expression will go. So we have 2A minus X whole square equals to X square, and then we'll remove the square from here. So 2A minus X equals to X. This implies 2X equals to 2A. This implies X equals to A. We'll put X, the value of X over here, right? So what will happen here is we'll get A square plus B square equals to 4A square. This implies P square equals to 3A square. This implies P equals to root 3A square, which is nothing but root of 3A. So this is root of 3A. Similarly, this one will also become root of 3A, and this as well will come out to be root of 3A. Alright, so this is all. We are going to discuss problem number 7, 8, 9 and 10 of chapter 6. In previous classes, we had discussed problem number from 1 to 6. Yes, now in today's class, we are going to discuss problem number 7 first. So let's start with this. So let's see the problem first. What is given in this problem is prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of the diagonals. So first of all, we need to understand what is a rhombus. Okay. Once we understand the rhombus, then we will understand the sides will be of equal length, and also the diagonals also will be of equal length. So let's first draw a rhombus and try to understand that property, odds property. Alright. So first of all, let's take a side which is this. Alright. And then let's take a copy of it as well, because the sides will be same, right? So like, taking a copy of it. So, and then let's rotate it by say 90 degrees. Now I have got another side of the rhombus. Now let's take another copy of it and then move this side over here. Let's take another copy of it. This side over here. Now let's draw the diagonals. Now let's call it A, B, C and D. So here the sides are AD, AB, BC and BC, and the diagonals are AC and ED.
So what we know, if we know the properties of rhombus, first the sides will be of equal length. So let's say if this side is of length A, this will be also of length A, this will be of length A, and this will be of length A. Second property is that the diagonals of the rhombus would be intersecting at 90 degrees. So all these angles will be 90 degree as well. And then finally, these two uh, diagonals will be bisecting each other. So it means that if I call this point as O, so AO will be equal to OC and OD will be equal to OB. So in this diagonal, in this rhombus, what all we have got is AO is equal to OC, OD is equals to OB, and AB equals to BC equals to CD equals to DA. Okay, what we need to prove over here is sum of the squares of the sides of a rhombus. So first of all, to prove, what we need to prove is to prove that AB square plus BC square plus CD square plus DA square is equal to the sum of the squares of a triangle. It means equals to AC square plus BD square. And since we have already written this is A, this is A, this is A, this is A, this implies that what we need to prove is A square plus A square plus A square plus A square equals to AC square plus BD square. This means 4A square equals to AC square plus BD square. This is what eventually we need to prove. So now we can go in this triangle. In triangle BOC, angle O is 90 degree. So we can use Pythagoras theorem. So from Pythagoras theorem, what we can write over here is OC square plus OB square equals to BC square. So we got OC square plus OB square equals to BC square. So now let's write it over here. Now OC square is nothing but OC square. Can we write AC as OC plus AO? And since AO is equal to OC, can we write it's nothing but OC plus OC? That is nothing but 2OC. So can we write AC equals to 2OC or OC equals to AC by 2? Similarly, my BD is nothing but OB plus OD, and we know that OD equals to OB. This means that we can write OB plus OB, since OB equals to OD. This implies this is 2OB. This implies BD is nothing but 2OB. This implies OB is nothing but BD by 2. Now, if we call it 1, let's call it 2, and we call it 3, we can use 1, 2 and 3, basically 1 and 2 in 3. So what we can write over here is, from here we can write OC square plus OB square plus 2BC square, which is nothing but OC square is AC by 2 whole square, AC by 2 whole square, plus OB square is nothing but BD by 2 whole square, and BC square is nothing but A. BC is nothing but A, right? This is nothing but A square. Again, we can write, let's move it a little further up. So we can write AC square by, AC square by 4 plus BD square by 4 equals to A square, or we can write AC square plus BD square equals to 4A square. This is what we needed to prove, and this is So we could have written it in any other way as well. If you wanted to write it like AC square plus BD square, we could have also written A square plus A square plus A square plus A square, and this was nothing but all these sides are equal, so we could have written AB square plus BC square plus CD square plus DS square. So yeah, we could have written it in any ways. So let's look at this problem again and then try to understand what all we did. So in this problem, we use the property of Pythagoras theorem when we knew that this is going to be a right angle triangle. We also knew that this side, all these sides will be equal. We also knew that these the diagonals will be bisecting each other. These things could be proved as well if you try to look at these triangles. Since in rhombus these sides are parallel, this AD is parallel to BC, this angle is equal to this angle is equal to this angle, and both the angles are equal because they are like facing each other, right? These two two angles are equal because these two lines are parallel, and this line is bisecting bisecting these two lines. So because of this angle is equal to this angle, right? So all these three angles are equal, so this means that this triangle is similar to this triangle. We could have also seen these two triangles are similar, and since this side is equal to this side, right, we know that all other sides will also be in the same ratio, so we could know that this side also will be equal to this side will also be equal to this side, then only this will be similar to this, right? So yeah, so this is already known to us, and we again tried proving it as well. So yeah, so this problem is done. Let's go to the next problem. Our next problem is this, which is, in this problem, there is a figure given, and O is a point from which there are perpendicular which are dropped. So it's saying O is a point in the interior of a triangle ABC. OD is perpendicular to BC. This is perpendicular to BC. OE is perpendicular to AC. This is perpendicular to AC, and OF is perpendicular to AB. So OF is perpendicular to AB. We have to show that OA square plus OB square plus OC square, and there are multiple other things. So first of all, there is something which is given here is OA square, right? And we see that it is not like joined, so we don't have that side, right? So first of all, let's try to join this side OA, and similarly try to join OB, and try to join OC. Rather, let me take the line so it will be drawn properly. So let me try to join OA, right? Try to join OB, and try to join OC, right? Once we have joined these sides, what we can see over here is that these triangles now are looking like, of course, they are looking like a right angle triangle, and once we have a right angle triangle, we know that we can use Pythagoras theorem. So let's try to calculate first these entities. So let's take our LHS. LHS is nothing but OA square plus OB square plus OC square. So these are squares, while writing this has not come properly. These answer square, minus OD square minus OE square minus OF square, right? So let's first write OA square. OA, when we go into this triangle OEA, so we can write OA square is nothing but OE square plus AE square, right? Similarly, OB square can be written as OD square plus BD square, and similarly we have to look at what we need to get. So we could have taken either this triangle or this triangle while calculating OC, but when we look at the other side, we see that there is another term which is CE square, right, and BD square and AF square. So we have to get C square, right? So C is in this triangle. So we'll go into this triangle OEC. And in OEC, what we can see here is OEC is OC square is nothing but OE square plus EC square. OE square plus EC square. And now we have other terms like OD square minus OE square minus OF square. So OD square is cancelled, OE square is cancelled, and you can see here what I have taken over here. This is not right. So OA square, what I have taken here is OA is OE and A, right? But I have OF over here, OF. So rather I should have gone into this triangle, right? So instead of writing this, so let me erase this part. So I should have taken what? I should have taken OF and AF. So I should have taken OF square plus AF square, right? So you could see that OF square is gone. Now what I am left with is AF square plus BD square plus AC square, right? So yeah, what we have to do is we have to look at the triangles and then use Pythagoras theorem to get to the entities which we want to, right? Now what is given over here is that AF square plus BD square plus C square, we need to prove A square plus CD square plus BF square. So we need to prove something like what is AF square plus BD square plus C square, and what is A square plus CD square plus BF square. So again, let's go into the triangle and then let's look at the triangles which we need to get. So we need to get AF is here, and then similarly we need to get BD, which is over here, and then we need to get CE, which is over here. So we know that these three triangles we need to go. So AF square, when we calculate in this triangle AFO, we can write AF square as nothing but, first let's write AF square plus BD square plus C square, right? Now for AF, let's go into triangle AFO. AF square is, what is AF square? So if we go in triangle, let's write triangle AFO. In triangle AFO, what I have is AO square is nothing but AF square plus FO square, right? So my AF square is what? AF square is AO square minus FO square, right? So I can write here AO square minus FO square. Similarly, BD square I can write BO square minus OD square, BO square minus OD square plus CE square. CE I can write as OC square minus OE square, OC square minus OE square, right? So this is what I have got. Now I can rearrange these entities again. Why? Because I need to get AE square. When you look at AE, what I have is this triangle. AE is in this triangle. So if I get AO and OE, then I can get AE, right? So let's put AO square and OE square together, right? I'll take AO from here, OE from here. Similarly, what I need to get is CD square. CD square is where? Where is CD square? CD square is here. So CD I have to go into this triangle. So what I need to get? OC square minus OD square. So I have to get OC square minus OD square. So do we have OC square? Yes, I have OC square. Do I have OD square? Yes, I have OD square. So I'll put OC square minus OD square together. So what I'm left with is BO square minus OF square, right? Now look at this. AO square minus OE square. AO square minus OE square, nothing but AE square. We will write AE square. OC square minus OD square. OC square minus OD square is nothing but DC square. Yeah, I'll write DC square. Similarly, BO square minus OF square. BO minus OF is nothing but BF square. BF square. So what is that we have got? We have got AE square plus DC square plus BF square, which is nothing but RHS, right? This is also proved. This is also proved, right? So now let's go to the next question. What is my next question? Or let's try to understand this question again better so that we don't have any confusion. So what was given earlier to us was the figure wherein something was asked which was not joined, like OA square was not joined, OB square was not joined, OC square was not joined. So what did we do first was we joined all these lines together first. Once we did that, we could see that okay, these triangles are forming my right angle triangles, and there are multiple right angle triangles formed. So there are almost not actually exactly six right angle triangles formed. So this is one, this is two, this is three, this is four, this is five, and this is six. So there are six right angle triangles formed, and every triangle has got some properties which we need to grow over here. So in the first one, we started with OA square plus OB square plus OC square. So when we did OA square, we wrote it in terms of OE square plus AE square, and similarly for others. And when we wrote that, we saw that the entities were getting cancelled out, and were left with something like RHS. In the next one, what we had to do was what we had to do in the next one was we had to start with one triangle, and we had to rearrange the entities to get the another triangle. So in the first one we started with this triangle, this was the first one. Then we started with BD, this triangle. Then we started with the third one, C, and we ended up with calculating this triangle, and this triangle, because all these sides, when we rearranged, we got the other sides as well. So this is what all we did in these two examples. Now let's go to the next one. Next one is this example. This question is talking about there is a ladder 10-meter long which is reaching a window 8 meters above the ground. Find the distance of the foot of the ladder from the base of the wall. So if you have looked at a wooden ladder, you would see that the wooden ladder is generally like kept like this. So if this is a ladder and this is, say, your wall, so it will be standing like this, because there are two ends to it and one has to support on the other. So this one will be on the floor. If this is your floor, this will be here, and the next part will be here. So this is what it is given over here. What it is saying that there is a wall and of course there is a floor like this, and then there is a ladder which is 10 meters long, which is reaching a window which is 8 meters above the ground. So if say this is your ladder, it's more like this, kind of ladder like this. It's like this. This ladder is like this, and your ladder is like this. Yeah, it's like this. So this ladder is 10 meters long. So this is what it is saying, and this is reaching a window. So there is a window over here, which is like this. There is a window over here, and it is reaching a window which is like 8 meters above the ground. So what we need to find the distance of the foot of the ladder from the base of the wall. So we have to find this length, the foot of the ladder from the base of the wall. So if it is O, this is my A, this is my B. So what we need to find is OB, wherein O is given, and we can see that this is a right angle triangle. Your walls are generally at right angle, if you could see your walls, right? So again here we have to just use Pythagoras theorem. From Pythagoras theorem, we have to write Pythagoras theorem. What we know is OB square plus OB square plus OA square equals to AB square. So base square plus height square equals to hypotenuse, right? So OB square is not given. OB square we write it like that. OA square is given, which is 8 square. AB square is given, which is 10 square. So now what we have is OB square, which is 100 minus 8 8 plus 64, which is again 36. So OB is square root of 36, which is nothing but 6. So this is 6 meters, and this is what will be your answer. So hopefully this problem is clear. This is very looks like a simple problem. So let's go to the next one. We'll go to the next one. What is my next problem? So a guy wire attached to a vertical pole of height 18 meters is 24 meters long and has a stake attached to the other end. How far from the base of the pole should the stake be given so that the wall will be drawn? So what is given again here is, so there is, looks like there is a pole, which is like this, there is a pole, and and what is there is that there is a wire which is attached to the vertical pole. So this pole has got some height, and there is a wire which is attached to this pole. So let's try look let's try it again. So what it is saying is that there is a stake attached here. So there is something over here which is like this, and the wire is attached to this and to this end, these two ends. This is the vertical pole, and this is height is given, which is like 80 meter. And there this wire is attached to this end, and it is saying that uh, the wire should be taut. It should be taut. So what it is saying that wire should not be like this. It should not be like this. It should not be a little curve or something like that. But rather it should be very taut, right? And if you are if your stake is not very far or it is here, so your line will be like this. So maybe your stake is over here somewhere. And when the stake is here, what will happen is that you draw this wire and this wire will be like taut and it will be attached like this. Alright, so this is how the wire is attached, and it is saying that this distance is almost how much it's given. It's given as this is not given, so we'll assume it as B. Alright, this is given 18 meter and this wire length is given 24 meter. So again, we can see this is gonna be perpendicular. This pole is vertical. It is saying it's a vertical pole, and it is like driven in the ground. So from the ground, when you take this angle, this will be 90 degree. And let's call it O again. Let's call it A and call it B. So what we need to calculate again here is we have to calculate OB. So we can say that AB square is nothing but OB square plus OA square. Again, from Pythagoras theorem, right? So AB square is given, which is the 24 square. AO square is given, which is 18 square. We need to calculate OB square, which I have just written. So OB square is 24 is 576, 818, it will be how much? 324, I guess. Let's calculate. I don't want to make a mistake. Let's say, right? And this is again 24. I'll just calculate. Right. So now we have got this. So 762, 725, and 532. Right. So OB square is square root of OB. So OB equals to square root of 252. We can factorize it. We'll see how many factors are coming. So how do we factorize it? We'll first divide it with the minimal possible divisor, which is 2. We'll get 2, 126. Then we again divide it by 2. We got 2, 6 is 12, 2, 3. And then we got 9 or 3 will divide it by 3. We got 21. Then we divided by 3, again we got 7. So what we got here is 2 square into 3 square into 7. So we can take out 2 square and 3 square. So we got 2 into 3 and then 7 remained inside. So this is nothing but 6 root 7. Yeah. So we got OB equals to 6 root 7 meter, and that will be your answer. Alright. Let's start with this problem first, which is this problem number 11. So it's given that an aeroplane is leaving an airport and flying due north at a speed of 1000 km per hour. At the same time, another airplane is leaving the same airport and flying due west at a speed of 1200 km per hour. How far apart will be the two planes after 1.5 hours? So if you look at the problem, what it is saying that there is a plane flying in one direction, another plane is flying in another direction, and so how far apart they will be at one particular point of time, right? So let's draw the figure and then we can understand this problem better. So say this is your system. So when you look at our directional system, this is treated as north, this is treated as south, this is treated as west, and this is treated as east. So one of the planes is flying in this direction north, another plane is flying in this direction west. This plane is moving at 1000 km per hour and another plane is moving at 1200 km per hour. So first of all, we need to know after 1.5 hours how far this plane would have moved and how far this plane would have gone. So assuming that this is the point from which they are starting, so let's understand in 1.5 hours how far the planes will be. So we know that the distance covered would be a speed into time, right? So now my speed is 1000 km per hour and my time is 1.5 hours. So 1.5. So this distance is 1500 km. Similarly, for the other plane, the distance covered would be 1200 km per hour into 1.5, which is nothing but 1800 km. So now what we have over here is one plane has moved for say 1500 km from here to here, and another plane has moved 1800 km from here to here. So now we have to find out the distance this one. Again, as you can see, this is nothing but a right angle triangle, right angle here, and this distance is 1000, this is 1500, so we can find out this distance, right? Calling it O, calling it A, calling it A. We know in right angle triangle, in triangle OAB, angle O is 90 degree. So this implies AB square equals to BO square plus OA square from Pythagoras theorem. Now BO square is nothing but 1500 km square. OA square is nothing but 1800 km square. So now 15, 15, 2, 2, 5, and then there will be 4 zeros. And then similarly 324 and then 4 zeros. Now when you sum it up, it will be 4, 5, 9, 2, 2, 4, 3, 2, 5, 5, 4, 9, and then 4 zeros. So AB would be what? AB would be square root of 5, 4, 9 into 10 to the power 4 we can write. Now look at 5, 4, 9. Can we factorize 5, 4, 9? Let's see. So since last digit is 9, so it will be divisible by 3. So let's write 3. So 1, 8, 3. Then again the last digit is 3, so it will be divisible by 3. 3, 6, 18 and 1. Now this number cannot be divided further. So we can write 3 square into 10 to the power 4 into 61. We take out these two integers outside of square root. So this becomes 3 into 10 square. So as you know, right, this is a square. So when we take out of this square root, it will become 3, and similarly to the power 4 will become to the power 2, and then 61 remains here, and this will become 300, and then this is 61 kilometer, right? So this is going to be your answer. Now let's move to the next problem. What's my next problem? My next problem is this one. It's given that there are two poles of heights 6 meter and 11 meter standing apart on a plain ground. If the distance between the feet of the poles is 12 meter, find the distance between their tops. So what is given is that there is a plain ground, something like this, there is a plain ground. So there is a pole standing which is say 11 meter of height, and then there is another plane which is like 6 meter of height. So we need to find out the distance between the tops of these two poles. We have been given the distance between the feet of these two poles, which is given as 12 meter. This is given as 6 meter. This entire thing is given as 11 meter. Now let's assume we drop a perpendicular from here to here. So since this is 6 meter, this will also become 6 meter. So this entire distance is 11 meter, this will become 5 meter. Since this is 12 meter, this will become 12 meter, right? Right angle, right? So call it A, B, C, D and E. Now in triangle DEC, using Pythagoras theorem, can we write BC square equals to DE square plus EC square? Why? Because angle is 90 degree. Now DC square is what we need to calculate. DE square is given as 12 meters square. This is given as 5 meters square. This will become 144. 12 square is 144. 5 square is 25. This will become 169. This becomes DC becomes square root of 169. This becomes 30, and that is the answer. Right? Now let's go to the next problem. That's my next problem. Let's read this problem. Given that there are D and E 2 points on the sides of C and CB respectively of triangle ABC, which is right angle at C, prove that A square equals to BD plus BD square equals to AB square plus B square. So let's first make the figure. Given that there is a right angle triangle, so let's make a right angle triangle first. There is a right angle triangle. Alright. Right angle at C, then this is A, this is B, and this is the right angle at C. Given that there are D and E points on side CA, so there is a point D somewhere here. There is a point E somewhere here is what is given. And now this is what is we need to prove. This is what we need to prove. AE square. We do not have AE as a side, right? So let's join AE. BD square. We do not have BD also. Let's join BD. Then equals to AB square. AB is already there. And DE is also not there. So let's join DE as well. Alright. So now you can see that there is a right angle triangle. This is also a right angle triangle. If you look at CED is a right angle triangle. CBD is a right angle triangle. CBA is a right angle triangle. CEA is a right angle triangle. So there are a lot of right angle triangles, and we can very well use Pythagoras theorem in all of them. So first of all, what is given? AE square. So let's write AE square and BD square, whatever is given on the left hand side. Let's write LHS. So LHS is given as AE square plus BD square. Now look at AE square. What is AE square when you are looking at in this triangle in ACE? So AE square is the hypotenuse. So this will be equal to sum of perpendicular and the base. So what is perpendicular? Perpendicular is CE. So we will write AE square is nothing but CE square plus AC square. AC is the base. Similarly, what is BD? BD square. When you look at BD, this is again part of this triangle, right angle triangle BCD. So BD is again hypotenuse. When BD is hypotenuse, then what will be BD square? BD square is nothing but height square plus base square. So BC square plus CD square. BC square plus CD square. Now my CE square is given, right? See, this is what we have done. Now on the right hand side, you can see that there is AB square, right? When you look at this bigger triangle, AB square is nothing but BC square plus CA square. So we can combine CA square and BC square together and CE square and CD square together. So let's put them together. AC square plus BC square together, and then rest of them together. CA square plus CD square. When you look at AC square plus BC square, AC square plus BC square is nothing but AB square in the bigger triangle ABC. So AB square. CE square plus CD square. CE square plus CD square is nothing but DE square in this triangle, because D is the hypotenuse in CED triangle. So this is basically this is your ED square. You can write it again as AB square plus D square. So maybe you want to write from triangle ABC and triangle CDE. Here as well, you could write in detail as to which triangle you have looked at and then how did you arrive at. You can write here using triangle AEC and triangle DBC. So here basically you can write this, here you can write, and in all of them using Pythagoras theorem is what we are using Pythagoras theorem. So you can see that all these problems are being solved using Pythagoras theorem. All you have to look at is that how to make this triangle a right angle triangle. Once you have done it, you look at the which is the hypotenuse, which is base, which is height, and then work with that. So this is how you will solve this problem. So let's look at another problem if we can, as we do have time. So let's look at this problem as well. What's this problem saying? So this problem is saying that the perpendicular from A on side BC of a triangle ABC intersects BC at D such that DB equals to 3CD. So DB, this part is equal to 3CD it seems, right? So look at BC. Look at BC. Say if any time when this kind of entity is given, right, you try to resolve it in the bigger side generally. Why? Because when you look at the entity which you need to prove, what we have over here is AB square, which is this side, AC square is this side, and BC square is this, right? You do not have CD or BD, right? So we try to reduce it into BC itself, right? So we can write BC is what? BC is CD plus DB. CD is alright, but DB is 3CD, so we'll write 3CD. This implies BC equals to 4CD. This implies CD equals to BC by 4. This implies DB equals to 3CD, right? Equals to 3 into what is CD? BC by 4, right? So this is what we have, 3BC by 4. Now let's look at LHS of it. What is LHS? Which is AB square, but rather 2AB square. So let's write LHS for the liquid. LHS equals to 2AB square. So 2 times AB square is what? AB square is nothing but AD square plus DB square. AD square plus DB square. Using again Pythagoras theorem. In triangle ADB. Now 2AD square. Look at AD. AD what would be AD in terms of AC and CD? So can we write AC square minus CD square? AD square equals to AC square minus CD square plus BD square. Since AC square equals to AD square plus CD square from Pythagoras theorem again, from Pythagoras theorem. Now you can write 2AC square is alright. Now write CD, what we have CD as BC, BC by 4 whole square plus what is my BD? BD is nothing but 3BC by 4 whole square. Is that it? Now my 2 AC square minus. Now let's take BC square by 16 plus 9BC square by 16. Further try to solve this part again. We have 2 AC square plus take 16 as LCM, then this will become minus 1, this will become 9BC square, alright, which is nothing but 2AC square plus 8 by 16 BC square. 8 2 is 16. So 1 by 2 BC square, which will become 2SE square plus BC square, which is nothing but RHS, right? So that we need to prove. It's given that in an equilateral triangle ABC, D is a point on side BC such that BD equals to 1 by 3rd BC. Prove that 9AD square equals to 7AD square. So let's draw the figure first. Okay, so we have drawn an equilateral triangle now ABC, and it's given that BD equals to 1 by 3 BC. So BD is somewhere here, D is somewhere here, and what's given is this BD is 1 by 3rd of BC. Alright, so BD is 1 by 3rd of BC is what is given. Now let's join this with A. Right, we are asked to prove that 9AD square equals to 7AB square. So we have just drawn AD so that it's given 9AD square equals to 7AB square. We have to prove. Now, if we look at this chapter, what do we know? We know some similarity conditions, we know some Pythagoras theorem and stuff, right? And here we do not have a right angle triangle. All we have is an equilateral triangle. So let's say if we assume that each side is of length A, so we are assuming this side is of length A, even this side is of length A, right? So what would be my BD? BD would be nothing but 1 by 3 of A, right? This is BC is A, right? So this is why it is. Now let's assume that we drop a perpendicular from here to here. Why do we do that? Why we are doing that is because we want to look at some right angle triangle and see that whether it is making sense for us. So let's drop a perpendicular from here. This is my construction. So I drop the perpendicular from here to this, right? And you remember when we did our exercise, the problem number 6, what we found that when you drop a perpendicular from a point on the other side of an equilateral triangle, this side will be divided into two equal parts. So basically this part from here to here, if I call it E, my PE will be A by 2, and similarly my EC will also be A by 2, right? So we will write PE is also A by 2 and my C is also A by 2. Now what we need to prove? We need to prove 9AD square equals to 7AB square is what we need to prove. To prove that, now let's take LHS of it. LHS is 9 times AD square, right? What is 9 times AD square? Or even further here, what we have here is 9AD square equals to, if I put AB equals to A because all the sides are equal length, right? So all we need to prove is 9AD square is equals to 7A square, right? So now 9AD square, we are doing this 9AD square, and we will look at the triangle AD, which is a right angle triangle. AD is hypotenuse, then AD square will be DE square plus AE square, isn't it? So we can write 9 times AD square is nothing but AE square plus DE square. We can write using Pythagoras theorem in triangle ADE. This is what we can write. So now look at 9 and then we have AE square. AE square again can be go in triangle AEC and then AE square can be written in terms of AC square and BC square. So AE square we are writing in terms of AC square minus AC square, right? And D we have already calculated D, we have not calculated D. So let's calculate D. What could be D? D is nothing but it's BE minus BD, BE minus BD, right? What is my B? B my A by 2. What is my BD? BD is A by 3, right? So A by 3. Now 6 would be my LCM and then here it will be 3 minus 2 into it, which is nothing but a by 6, right? Now, so let's put d equals to a by 6 whole square. This is what we will do, right? And now close it with bigger bracket. Now look at AC square. AC square is nothing but a square. We can, and here as well you can write using Pythagoras theorem in triangle AEC. You can write AC square equals to AE square plus EC square. Right? Now this is 9. Now AC square is nothing but A square. EC square is nothing but A by 2 whole square. And then this D square is nothing but A square by 36. This now we have calculated. Now write it down. Now A square, let's take A square common. Then what we are left with is 1 minus 1 by 4 plus 1 by 36. Right? Now this is nothing but 9. And then take 36 as LCM. So what we have over here is 36 minus 9 plus 1. Right? Now 36 minus 9 is 27 plus 1, 28. This is 28 into 9 by 36, and we have a square as well. We have to write a square as well. Now this 9 4 the 36, 4 7 the this, and we have a square, which is nothing but a square. Now either a square can be written in terms of 7, and we can write ab square, right? So this is what is that we have to prove in right hand side. This is what we have to prove. This is proof. Now let's look at the next problem. In an equilateral triangle, prove that 3 times of the square of one side is equal to 4 times the square of one side. So first let's draw the figure and then see. So this is my equilateral triangle. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of another side. So let's first draw up an altitude from here to here. So this is my altitude, right? Now we call it D. So what it is saying here is that 4 times the square of its altitude, 4 times AD square should be equal to 3 times the square of one of its 3 times the square of one of its sides. So 3 times, call it AC square, or 3 times AB square, or 3 times BC square, because it is an equilateral triangle. This is what we have to prove that, right? Now again let's call this side as A, call it this side as A, and again this side as A, right? We remember that when you drop a perpendicular from one of its vertices to other side of an equilateral triangle, it will divide the side into equal ratios. This will be A by 2, this will be A by 2, right? Now since this is A by 2, this is A, now we can calculate AD. So in triangle, in right angle triangle ADC. So what you can, in right angle triangle ADC, you can write AC square equals to AD square plus DC square, right? What is your AC square? AC square is nothing but A square is what we had assumed. AD square, what is your AD square is what we are supposed to calculate. What is your DC square? DC square is A by 2 whole square, right? Now, what is your AD square? AD square is A square minus A square by 4, which is nothing but 3A square by 4, right? Which is again, we can write 4 AD square equals to 3A square, and A, as we have seen, can be written as either 3AC square or 3AB square or 3BC square, right? So this is what we have to prove. So this is what is proved, right? Now let's go to the next problem. What is my next problem? This is my last problem. So take the correct answer and justify. In triangle ABC, AB equals to 6 to 3 centimeter, AC equals to 12 centimeter, and BC equals to 6 centimeters. The angle B is. So let's say if this being the case, I'm just trying to draw a right angle triangle and see whether this being the case, because this is what is given. So I'm just saying this is my A, right? This is my B, this is my C. AB is given as 6 root 3 centimeter, AC is given as 12 centimeter, and BC is given as 6 centimeter, right? So let's try to calculate what is AB square. My AB square is nothing but 6 root 3 whole square, which is nothing but 36 3108, right? What is my BC square? BC square is nothing but 6 square, which is nothing but 36, right? What is my AC square? AC square is 12 square, which is nothing but 144. Now let's sum up AB square plus BC square. What do we get? We get 108 plus 36, which is nothing but 144, which is nothing but AC square, right? So in any triangle, if a square, sum of the square of two sides is equal to the square of the third side, then it's a right angle triangle. So can we say that it's a right angle triangle and angle B equals to 90 degree, right? This is what you have, and 90 degree would be the answer. Why it is the case? Because it's a converse of Pythagoras theorem. Right? So from the converse of Pythagoras theorem, we can say that if AB square plus BC square plus AC square, then angle B is equals to 90 degree. Alright. So these were the problems in chapter 6.5. So we are done with it right now. So yeah, thank you so much.